What causes A to overallocate? Apparently lister doesn't overallocate, x for x in A overallocates at some points, and A overallocates all the time. Here are sizes n from 0 to 12, and the resulting sizes in bytes for the three methods. Computed like this, reproducible at REPL.it, using Python 3.8. So, how does this work? How does A overallocate? Actually, what mechanism does it use to create the result list from the given input? Does it use an iterator over A and use something like list.append? Where is the source code? Collab with data code that produced the images. Zooming into smaller n. Zooming out to larger n.
A is internally doing the C equivalent of make a new, empty list, call new list.extend A, returns list. So if you expand your test to try it online. You'll see the results for getSize of A and L equals L.extend A, getSize of L are the same. This is usually the right thing to do. When extending, you're usually expecting to add more later, and similarly for generalized unpacking, it's assumed that multiple things will be added one after the other. A is not the normal case. Python assumes there are multiple items or iterables being added to the list A, B, C, D, so overallocation saves work in the common case. By contrast, a list constructed from a single, pre-sized iterable with list may not grow or shrink during use, and overallocating is premature until proven otherwise. Python recently fixed a bug that made the constructor overallocate even for inputs with known size. As for list comprehensions, they're effectively equivalent to repeated appends, so you're seeing the final result of the normal overallocation growth pattern when adding an element at a time. To be clear, none of this is a language guarantee. It's just how Python implements it. The Python language spec is generally unconcerned with specific growth patterns in lists, aside from guaranteeing amortized O1 appends and pops from the end. As noted in the comments, the specific implementation changes again in 3.9. While it won't affect A, it could affect other cases where what used to be built a temporary tuple of individual items and then extend with the tuple now becomes multiple applications of list_append, which can change when the overallocation occurs and what numbers go into the calculation.
Full picture of what happens, building on the other answers and comments, especially Shadow Ranger's answer, which also explains why it's done like that. Disassembling shows that build_list_unpack gets used. That's handled in cval.c, which builds an empty list and extends it, with A. _pylist_extend uses list_extend, which calls list_resize with the sum of the sizes. and that overallocates as follows. Let's check that. Compute the expected number of spots with the formula above, and compute the expected byte size by multiplying it with 8, as I'm using 64-bit Python here, and adding an empty list's byte size, i.e., a list object's constant overhead. Output. Matches except for n equals 0, which list_extend actually shortcuts, so actually that matches too.
These are going to be implementation details of the Python interpreter, and so may not be consistent across other interpreters. That said, you can see where the comprehension and listed behaviors come in here. This URL, specifically for the comprehension. Just below those lines, there is list_preallocate_exact, which is used when calling list A.
If you want to see more, these things will subscribe you.